Everyone, so we're looking at class 2 right now. So it's a little bit with graphing. So throughout the year, when you have any questions with graphing, I'm going to point you to class 2 very frequently. So make sure you have the information here um, very accurate, and feel free to refer back to this video as you need. So let's check out this graph here. This says what two quantities or what quantities does this graph measure? It measures mass and volume. What does it tell you about their relationship? Well, the main answer I'm looking for is as mass goes up, volume goes up, or as volume goes up, mass goes up. You can say it either way. I think it would be more correct to say as volume goes up, mass goes up, but it doesn't really matter. The other thing you could say is you could say that this graph is linear. A lot of you were saying that. This graph has a direct relationship. It has a positive relationship. All of those are right. A couple of them that I'm really going to emphasize, though, are linear, and as one goes up, the other goes up. Find the slope and determine its meaning. So really important when you find the slope. I really emphasize I don't even use the data points to find the slope. I use strictly the line of best fit. Let's keep it easy though. I'm going to use, let's see. So these lines should be straight when you draw them, but mine won't be. Let's see, my run will be to 100 because that's easy. And I'm going to go straight up to the line from there. I'm not necessarily going to that red point there. I'm going to the line. So my run is 100 milliliters. And my rise is, let's call that, I don't know, it's a little more than 450, maybe 460. Yeah, I think that's, actually, never mind. That goes between 4 and 600. So it's a little bit more than halfway, so a little bit more than 500. So let's call it like 550. That's reasonable. Maybe not even. Let's just call it 510 grams. Okay. So slope is rise over run. That's how we're going to do it in this class. And let me just get rid of that. So our rise is going to be 510 grams. Our run, 100 milliliters. And we have 5.1 grams per milliliter. So that's our slope. Now, what is its meaning? This is density. All right. Mass per unit volume. So let's go through how to create a graph by hand. So we took some data in class of me walking across the front of the room. I don't have that data on hand, so I'm just going to make it up. All right. So our displacements, I think we went from 0, 1, 2, 3, 4, and 5. And I think our times, I don't know, time 0 was displacement 0. Let's keep it easy. Let's just say it was 2 seconds, 4, 6, 8, and 10. Every class was a little different, but it's fine. Time is always going to be on the x-axis, always. Anytime you see time anyway, as long as it's one of the two variables. So let's put time on the x-axis, and let's put displacement on the y. I'm just going to write DISP just to keep it short, and you can put the units in parentheses there. So we're going to call this graph, it's always y versus x. Displacement versus time. All right, so these are just some of the basics. Now let's graph the data. So we're going to put some data points down. Actually, before we do that, we have to get the scale. So the time, let's see, the time goes up to 10 seconds. So maybe every box will be 1 second. So 0, 2, 4, 6, 8, and 10. And over here, let's say every 2 boxes is 1 meter. So 1, 2, 3, 4, 5. It's really important to use at least half the graph. All right, so our first data point, let's do the data points in a different color. Let's go with blue. All right, so our first data point is 0, 0. Our next data point is 1 and 2. 2, oh, it's actually going to end up being pretty perfect because this data is made up. It's not real data. Our real data that you took in class is a little bit less perfect than this. We're going to do a line of best fit. Now, the line of best fit is going to perfectly go through the data, but that's not always the case. Kind of regret making a perfect line now. But yeah, this is going to like perfectly go through all the data. Once I can get it to see, look at that, perfect. So our line of best fit's really good. All right, so that's like a perfect graph. Yours in class, the line of best fit kind of went through the data. Definitely missed some of the data points, but that's fine. It shouldn't be perfect. So just to rehash a few things, labels, okay, I already said this, but you should title your axis or each axis with units. Title your graph. It's always going to be whatever is on the y-axis versus whatever is on the x-axis. Okay, so it's always y versus x. In this case, that would be displacement versus time. Number your axes, each axis evenly. Okay, so make sure it's even increments. Plot your data, add your line of best fit. Are we connecting the dots? No, absolutely not. You're just drawing a straight line using a straight edge that goes through the data pretty well. Now, this graph checklist thing, in the past I used to give students a graph checklist, but this is what's on your graph checklist. Did you label everything? Did you plot your data well? Did you add a line of best fit? I'm going to add one more thing though. One more thing is, did you use at least half the area? Okay, so make sure your graph isn't just bunched into one corner of the given area. So we're going to find the slope using rise over run. So let's go back up here. So I'm going to choose yet a different color for this one. Actually, black might work here because it's not used on this graph yet. So my run is going to say, let's go to 10 because that's easy. 10 seconds. And my rise, let's see, we go up to almost exactly 5. So about 5 meters. I did not choose the data points 5 and 10. No, I just did a rise and run. I went to the line of best fit. Once you draw your line of best fit, honestly, as long as it's good, you can ignore your data points at that point when you find the slope. So slope equals rise over run, 5 meters over 10 seconds, 0.5 meters per second. The units for the slope is always going to be your y unit over your x unit. Okay? Interpret your answer. What does the slope represent? Meters per second. So we have a distance per unit time. That in this class is going to be speed or velocity. They're the same thing for now, but we will talk about why they are different. All right. Now this exit ticket here was something for you to work on your own, but I will go through the answer. All right, so you're plotting this data with volume on the y. So we have volume in milliliters and mass in grams. All right, so let's see, this is 0. We'll go 10, 20, 30, 40, and 50. And we're going to go, let's see, 1, 2, 3, 4, 5. That should be pretty good. So we have one data point right here. That data point is going to be 0, 0. Then we have 1.1 and 10. So a little bit right there. Then we have 2 and 20. Then we have 2.8 and 30. So let's see, that should be about there. Then we have 3.9 and 40, so just below 4. And 4.2 and 50. So a lot of students pointed out this last one is a terrible data point, but I mean, it happens. You can retake data points, but sometimes you're just kind of stuck with it. Now, if we go to find or put in the line of best fit, you'll notice that it's a little bit difficult to do, okay? Because you have to think to yourself, okay, that wasn't good. Let me go back to that. So you have to think to yourself, okay, do I go through these points here? Do I go through this one here? Well, it's going to kind of be like this. It's going to be much closer to all these data points because there's a lot of them that are more or less in a straight line, but it's definitely going to be skewing a little bit towards that other that last data point. So maybe something like this. There's some margin for error here. Next class, we're going to talk about the perfect way to do this, but there is a margin of error. So now using my line of best fit, I'm going to do rise over run. I'm not picking data points. Okay, so let's do rise over run to get the slope. I'll do it in blue. I'm going to go over to 50. So my run is going to be 50 milliliters. Oops, milliliters. My rise is going to be, that looks like about 4.6. I think that's reasonable. Just making sure that that's right. Yeah, about 4.6 grams. So to find our slope, that's rise over run. Slope equals rise over run. So that's going to be 4.6 grams over 50 milliliters. All right, I have to get a calculator out really quickly to do that. That's going to be 0.092 grams per milliliter. All right, so that would be your answer there, your slope. All right, have a good one. Let me know if you have any questions, and I will see you all around.